Hello, sorry for the late video, but I just remembered there was a quiz, an hour ago. So, we all get forgetful sometimes. But so here is the video on percent yield. And you've probably noticed this is a lot like the other percent problems we've done last semester, just new things and the ratio. So it's not too hard. The hardest part is the stoichiometry. So that's great. So what percent yield is it describes how closely the theoretical yield is, or the yield you calculate you will get, is to the actual yield, the yield you got in the lab. So the formula for this is that your percent yield equals the actual yield over the theoretical yield times 100. Just remember that 100, or that percent sign, is just a unit, not 100%. And if you want to put this in other words, you can say what you got in the lab over what you calculated you'd get. So let me do one example if my computer decides to cooperate. Okay, so say you have 0.5 grams H2, and it reacts with O2 to produce, there's a C, water. Okay, 35.0 grams of water were produced in the lab. What is the percent yield? So when you're doing these, something you might be confused about is you have two numbers here in the problem. So I think the easiest thing first is to set up the equation. So this is a synthesis, since you're taking two elements by themselves and combining them. So we have H2 plus O2 gives you H2O, 2 here, 2 here. So now we have our balanced equation. So now we need to do our stoichiometry. So it might be helpful to write what you're given under the numbers they go with. So as you can see here, we have 5 grams of a reactant and we have 35 grams of the product. So whatever, for percent yield problems, whatever the number they give you that's the product, that's not the one. You start with the amount of the reactant, because this is what you actually got in the lab, and we're trying to calculate how much you should have gotten with our stoichiometry. So we're going to start with this 5 grams. So 0.5 grams of hydrogen over, and then just kind of follow the pattern that stoichiometry has. Molar mass of the given over 1 mole of the given times the molar ratio. So the molar ratio for this is from the equation 2 moles hydrogen over 2 moles of water. But since 2 and 2 can reduce, just like they can in normal math, you can make this 1 and 1, so you have less things to push in. Say this is 2 and 4, you can make it 1 and 2. Just, look out for those patterns, less things to put in the calculator. And then, so we have the kind of pattern going, we have our molar ratio, and then we have the grams of we're trying to find, and then the moles of what we're trying to find. So as you can see, everything crosses out. We are left with moles, and that gives us, I'm going to write that down here, 44.6 grams of water. So this is our theoretical yield. So this is how many grams. The equation goes perfectly. Everything's great. This is how much you should have produced. This 35 is our actual yield. That's what we got in the lab, where things can go a bit awry sometimes, and you might just not have done it correctly. A lot of times, for the most part, your theoretical yield will be bigger than your actual yield, since you'll probably lose some stuff to just human nature. So now's the time, now we've done all the stoichiometry, now's the time to actually find out what our percent yield is. So just following our formula, we put our actual yield over our theoretical yield times 100. Plug that all in the calculator and round to sig figs, you get 78.5%. So when we did this in the lab, we got 78.5% of what we were supposed to produce, is what that means. So that's basically all for percent yield. The thing you need to be careful of is knowing which numbers to use from the problem, and just remember to start with whatever is the reactant or on the left side, because this is your product number, and that's what you actually got. So just read carefully and do your stoichiometry correctly, and you will be all good. Thank you so much for watching. Let me know if you have any questions or anything, need me to do another video. Yep, that's basically it. Good luck.